You've probably heard that the universe is expanding way faster than it's supposed to, and that a mysterious force called dark energy is supposedly driving this cosmic speed up. But what if that's all just an illusion? Physicist Lucas Lombrizer is challenging everything we thought we knew, arguing that the universe isn't racing outward at all. Instead, he says the cosmos is flat, still, and static. So what could possibly back up such a mind-bending claim? Could science really have gotten one of its biggest ideas completely wrong? Stick around till the end as we break down this bold new theory. History reminds us just how often our understanding of the universe gets flipped on its head. A century ago, even giants like Einstein believed the cosmos was eternal and unchanging. At that time, many scientists thought our Milky Way was the only galaxy in existence.
But then came Edwin Hubble.
While studying strange, spiral-shaped clouds in the night sky, he made a game-changing discovery. Those nebulae weren't part of our galaxy, they were entire galaxies themselves. That single revelation completely rewrote our cosmic map. And it might not be the last time we need to start over. After Hubble expanded the known universe virtually overnight, he dove even deeper, measuring the redshifts of distant galaxies and sorting them by distance, size, shape, and brightness. That's when he stumbled upon something extraordinary. The farther a galaxy is from us, the greater its redshift. In simpler terms, the more distant a galaxy, the faster it's racing away from us. This consistent pattern led Hubble to identify a fixed relationship between redshift and distance, a concept now known as the Hubble constant. And with that, he became the first to confirm what now seems foundational in astronomy.
This discovery didn't just rewrite textbooks. It opened a window into the very birth of the cosmos. If everything is expanding outward, then rolling the clock backward leads us to a single, dense, unimaginably small origin point. That point is what we now call the singularity, the birthplace of space, time, and matter in the Big Bang. For decades, this model of the universe's evolution felt solid. We had a beginning, we had an expansion, and we even had the math to back it up. But then, the universe threw another curveball. In the 1990s, astronomers made a shocking observation. Instead of slowing down after its explosive start, the expansion of the universe had started speeding up about 6 billion years ago. It was a complete twist, one that left scientists scrambling for answers and opened the door to mysterious new forces like dark energy, or possibly, as some argue today, an illusion we've misunderstood all along. But if gravity is supposed to be the universe's great anchor, why hasn't it slowed everything down?
That's the puzzle that left scientists reeling. If space was expanding, gravity should have gradually pumped the brakes over time. To explain this cosmic contradiction, astronomers introduced a mysterious, invisible force now known as dark energy. Dark energy, the great counter to gravity, supposedly makes up around 70% of the universe's total energy. It's considered the driving engine behind our universe's accelerating expansion. But here's the twist. It can't be seen, touched, or measured directly. All we have are theories, fascinating guesses trying to pin down an entity that shapes the fate of the cosmos. And just when things couldn't get weirder, the James Webb Space Telescope entered the scene. Not only did it uncover ancient galaxies that are way too massive for their age, essentially cosmic toddlers with the heft of grown giants, it also threw new fuel on the fire of the expansion mystery. At the heart of this lies the Hubble constant, the number used to measure how fast the universe is expanding. But here's the catch. Different methods of measuring it are giving us different results. Webb's deep space data has only made this divide even more glaring. The farther we look, the more confused we get. Is the expansion accelerating faster than we thought, or have we misunderstood the very mechanics of space? Here's where things get seriously weird. The numbers just don't add up. According to the standard model of cosmology, the Hubble constant, the rate at which the universe is expanding, should sit comfortably at 67 kilometers per second per megaparsec. But reality has other plans. Observations based on distant supernovae, gravitational lenses, and ancient stars show a stubbornly higher number, around 73.
It's not a minor glitch, it's a major cosmological crisis. To double-check the numbers, scientists turned to the James Webb Space Telescope. Re-examining data first captured by Hubble, Webb offered a fresh, sharper look into the cosmos. And the verdict? 72.6 kilometers per second per megaparsec. Once again, reality defies theory. No matter how they slice it, the results suggest the universe is expanding faster than our models can explain, and nobody seems to know why. Well, almost nobody.
I spent all my life developing a particular theory of the universe, and now that theory is being questioned. I welcome that, because that's how we move forward. That's how we make progress in science.
Enter Lucas Lombrizer, a theoretical physicist from the University of Geneva who just dropped a cosmic bombshell. He suggests that the universe isn't expanding at all. According to his radical theory, published in Classical and Quantum Gravity, what we perceive as expansion could be a total illusion. Instead of racing outward, the cosmos might be flat, static, and motionless. So what's backing this shocking claim? Lombrizer and his team aren't just speculating, they're rewriting the laws of physics, mathematically reformulating how we interpret space and time. If he's right, it wouldn't just patch up the Hubble discrepancy, it would shatter our entire understanding of the universe. Lucas Lombrizer's theory doesn't just challenge the idea that the universe is expanding, it flips the entire cosmic script. According to him, the redshift we see in distant galaxies, the same redshift that's been used for decades as evidence of expansion, can be explained another way, through the changing masses of particles like protons and electrons over time. In other words, it's not space stretching, it's the particles themselves evolving. Instead of a ballooning universe, Lombrizer proposes a cosmic field that fills all of space-time. This field is where particles form, exist, and move. And it's this field, not the stretching of space, that causes the redshift. Within this framework, the infamous cosmological constant isn't tied to expansion at all. It's a reflection of the mass of the field itself, and as the field fluctuates, so does the constant. That's a huge shift in perspective. But here's where things get really wild. His model fits the redshift data perfectly. Lombrizer even admitted he was shocked at how neatly this new picture erased the persistent cosmological constant problem. And this same model might just offer answers to two of the biggest mysteries in astrophysics, dark matter and dark energy. Traditionally, dark matter was invented to explain why galaxies rotate faster than visible matter alone can account for. It's believed to outweigh normal matter 5-to-1, but we've never seen it. Lombrizer argues that the fluctuations in his proposed field might act like an axion field, a candidate for dark matter made up of hypothetical, neutral particles with no spin. If true, it could mean dark matter isn't a separate substance at all, but just a quirk of how this universal field behaves. Even more fascinating, those same field fluctuations might be the key to unlocking the nature of dark energy too, the force that supposedly drives the universe's acceleration. So, instead of two invisible, unexplained forces propping up our models, we might be looking at one unified field behind it all. According to Lucas Lombrizer, the strange force we call dark energy might not even exist. He believes its effects can be explained by something far simpler, a shift in the development of particle masses later in the universe's timeline. In this view, there is no need for dark energy at all, just a universe governed by a fluctuating cosmic field that changes how matter behaves over time. But how has the scientific community responded to this radical idea? One notable voice, Luz Angela Garcia from Colombia's Universidad ECCI, finds the theory fascinating. Even though she wasn't involved in the research, she called it an unusual result for several problems in cosmology and praised its potential to offer a way out of the mounting tensions surrounding current cosmic models. Still, she urges caution. While the model is elegant and intellectually appealing, Garcia reminds us that many of its key elements can't be tested with current technology. The cosmic field Lombrizer proposes, and the idea that particle mass development replaces dark energy, may remain theoretical for now, simply because we don't yet have the tools to confirm or deny its existence. So, does this mean we're heading back to the old belief in a static, unchanging universe? Not quite. As exciting as Lombrizer's theory is, the scientific world is proceeding with the careful skepticism that groundbreaking ideas deserve. For now, we're left in cosmic limbo, with one foot in our current expanding universe model. But speaking of Axiom, please join us now and press the thumbs up and subscribe button to never miss a new video from us again.